Students, in last class we discussed about problems based on gravity. In this class we will discuss mass, weight, center of gravity. First of all, we will discuss about mass. What is mass? The mass of a body is the quantity of matter contained in it. Mass of a body is the quantity of matter contained in it. If you observe any object, if you take any body, it will contain some matter. The quantity of matter contained in it is called mass of the body. Mass of a body is measure of inertia. Mass is the measure of inertia. Greater the mass, greater will be the inertia of the body, and hence called inertial mass. Mass of the body also called as inertial mass. Mass is a scalar quantity. Mass is a scalar quantity. It has only magnitude but no direction. That's why it is a scalar quantity. SI unit of mass is kilogram. CGS unit of mass is gram. SI unit of the mass is kilogram and CGS unit of the mass is gram. Mass of body is constant and does not change from place to place. Mass of body is constant. It does not change from place to place. It is constant throughout the universe, anywhere in the universe. Mass is measured by a beam or common balance. Mass is measured with beam balance or common balance. Here we can see beam balance, common balance. Mass of a body cannot be zero. Mass of a body cannot be zero because every object, every substance contains some matter, so it cannot be zero. Now we will discuss about weight. The weight of a body is the force of attraction on the body due to the earth. You know, earth has gravitational force of attraction on every object. Weight of a body is the force of attraction on the body due to earth. From Newton's second law, we know F is equal ma. Weight is equal, W is equal, M is the mass. In place of A, we are substituting G. A is the acceleration, G is acceleration due to gravity. Weight is due to the acceleration due to gravity of the earth. That's why in place of A, we are writing G. So, formula for weight is equal mg. SI unit of weight is newtons. SI unit of weight is newtons. It is represented by capital N. It is named after Sir Isaac Newton. Weight of 1 kilogram mass is, here mass is 1 kilogram. So, weight is equal 1 into 9.8. G value is 9.8. That equal 9.8 newtons. Weight of 2 kilogram mass is, here mass is 2 kilograms. 2 into 9.8. That is 19.6 newtons. Weight is a vector quantity since it has both magnitude and direction. Weight has magnitude and direction. That's why it is a vector quantity. Weight changes from place to place. Weight changes from place to place. On the moon, weight will be different. On the earth, weight will be different. On the moon, acceleration due to gravity is nearly 1/6 of that on the earth. Already we discussed. On the moon, acceleration due to gravity is nearly 1/6 of that on the earth. Hence, the weight of a body on the moon is 1/6 of its weight on the earth. For example, weight of the body on earth is 60 kilograms. Then it will be 1 by 6 into 60, that equal 10 kilograms on the moon. Weight is measured by a spring balance. Weight is measured by a spring balance. Weight of a body can be 0. Weight of body can be 0. If acceleration due to gravity is 0, then weight of the body will become 0. When a body is taken to the center of the earth, at the center of the earth, acceleration due to gravity is 0. So, when a body is taken to the center of the earth, then its weight will be 0. Now we will see one activity, measuring the weight of free fall body. Measuring the weight of free fall body. Take a spring balance and suspend it to the ceiling. First of all, take a spring balance and suspend it to the ceiling. Put some weight to it. Hang some weights to the spring balance. Note the reading of the spring balance. When we suspend some weights to the spring balance, it will note the weight of the objects. Now drop the spring balance with load from certain height to fall freely. Now drop the spring balance from certain height to fall freely. Carefully observe the changes in the position of indicator on the spring balance scale while it is in free fall. When it is falling freely, carefully observe the reading in the spring balance. Here we can see spring balance. It is suspended to the ceiling and there are some weights hanged to the spring balance. Then it will show the weight of the object. Here we can see spring balance. It is falling freely. When it is falling freely, it is show 0 weight, weightlessness. We observe that the indicator of spring balance shows 0 while it is in free fall. When it is falling freely, the indicator of the spring balance will show 0. The weightlessness of a free fall body. When a body is falling freely, it experiences weightlessness. Some of you might have the experience of diving into a swimming pool from certain height. When you diving into a swimming pool from certain height, what are your observations? You will observe that you feel weightlessness, because you are the freely falling body in that case. Now we will see another activity. Take a transparent tray and make holes on opposite sides. Take one transparent tray, make holes on opposite sides. Take 2 or 3 rubber bands and tie them tightly. Take 2 or 3 rubber bands and tie them tightly close to each other between the holes. That rubber band should be tied between the holes. Now place a stone on the bands. Now take one stone and place a stone on the bands. Here there is a transparent tray. There are 2 holes on opposite sides. 3 rubber bands are taken and they are tied between 2 holes. And a stone is placed on the bands. When a stone is placed on the bands, what we will observe? We observe that bands bend due to the weight of stone. Stone have some weight. Due to the weight of the stone, bands will bend downwards. Now drop the tray with stone. Now drop the tray with stone. Here the tray along with stone is falling freely. we observe that the bands do not bend, they are straight. No stretch occur in the rubber bands. When it is falling freely, the stone will experience weightlessness. That's why no stretch occur in the rubber bands, they are straight. We treated the weight of an object as the force due to gravity upon it. Already we discussed weight of an object is due to the gravitational force of attraction on object. When in equilibrium on a firm surface, weight is balanced by support force. When an object is on a firm surface, weight is balanced by a support force of the surface. When in suspension, if the object is suspended, then it is balanced by support in tension. A string has tension, a thread has tension, so it is supported by tension. In either case, with no acceleration, weight equal to mg. Weight is equal to mg. Already we discussed. A support force can occur without regard to gravity. Without regard to gravity, a support force can occur. The definition of weight of something is the net force it exerts against a support. So, we can say definition of the weight in another way. That is, net force it exerts against a support. Weight is a net force it exerts against a support. When the body falls freely, then it experiences weightlessness. Already we discussed, when the body falls freely, then it experiences weightlessness. Even in this weightlessness condition, there is a still gravitational force acting on the body, causing downward acceleration. But because there is no support force, the weight appears to be zero. Why it feels weightlessness? Even in freely falling condition also, there is a gravitational force acting on the body. But there is no support force when object is falling freely. That's why weight appears to be zero. Now we will see another activity, balancing a spoon and fork. Balancing a spoon and fork. Arrange a fork, spoon and wooden matchstick together. Take a fork, spoon and wooden matchstick, arrange them together. The combination will balance nicely on the edge of the glass. The combination will balance nicely on the edge of the glass. Here we can see matchstick, fork and spoon will balance nicely on the edge of the glass. What happened here? The weight of the spoon and fork will pass through the center of gravity and the base of the glass. It will pass through the center of gravity and base of the glass. So, it is nicely balanced on the edge of the glass. Now we will see another activity. Sit in a chair comfortably. Try to get from the chair without bending your body or legs. Try to get from the chair without bending your body or legs. He is trying to get up from the chair without bending his body or legs. We are not able to do so because we should bend to make stability by shifting center of gravity and base in a line. Without bending our body or legs, we are not able to get up because we should bend, make stability by shifting center of gravity and base in a line. To shift center of gravity and base in a line, When we are getting, we should bend our body or legs. The center of gravity is simply the average position of weight distribution. What is center of gravity? It is a average position of the weight distribution. Now we will see the definition. Point where total weight appears to act is called center of gravity. Center of gravity is nothing but a point where total weight appears to act. Here we can understand by seeing this. Here a scale is there. The weight of the different parts of the scale acts downwards at different points, but at the middle total weight appears to act. By supporting with a finger at the middle, we can balance the scale. Why it is possible? Because the total weight of the scale appears to act at the middle of the scale. That point is the center of gravity. The point where total weight appears to act is called center of gravity. The position of center of gravity is different for different objects. For different objects, the position of the center of gravity is different. It is depend on shape and mass distribution of the body. Center of gravity position is depends on shape and mass distribution of the body. The center of gravity of a uniform object is at its midpoint. If you take regular object or uniform object, the center of gravity lies at the midpoint or geometric center. Here we can see a rectangle, a circle, a cylinder. For all these objects, center of gravity lies at the midpoint or geometric center. Here we can see a triangle. For all the uniform objects or regular shaped objects, center of gravity lies at the midpoint. Now we will see another activity to find center of gravity of an object. For a regular shaped object, we can find the center of gravity, that is at geometric center. For irregular shaped object, how we can find the center of gravity? Take an object. It is better to take irregular shaped object. Fix thread of a bob top of the object and suspend the bob. Take one object. Take a bob. Fix thread of the bob top of the object and suspend the bob. Suspend the bob by using the thread. Draw a line along the bob. Draw a line along the bob. Here we can see a regular shaped object. A bob is suspended from the object. Now draw a line along the thread or along the bob. Change the direction of the object. Now change the direction of the object. Again fix the thread of the bob at the top in the middle of the object and suspend the bob. Again fix the thread and bob at the top in the middle of the object and suspend the bob. Again draw the line along the thread. Now again draw the line along the thread. The center of gravity lies where two lines intersect. Here there is a irregular shaped object. When we suspend a plumb line or bob, it always toward the downwards. Draw a line along the thread. Now suspend the object from another point. Again draw a line along the thread. The center of gravity lies where two lines intersect. That is the procedure to find the center of gravity for a irregular shaped object or any shaped regular shaped object. The location of center of gravity is important for stability. What is the importance of center of gravity? The location of center of gravity is important for stability. if we draw a line straight down from the center of gravity of an object of any shape, it falls inside the base of the object, then the object will be stable. If it falls inside the base of the object, then it is stable. If the line through the center of gravity falls outside the base of the object, it will be unstable. Here we can see a person standing. Its center of gravity falls inside the base. So he is stable. He can able to stand. Here we can see the center of gravity falls outside the base. So he is unstable. So he will fall down, because center of gravity lies outside of the base. Here we can see a person walking on a rope by using a long pole. What is the use of this long pole? By using the long pole, he always try to pass his center of gravity along the rope, so he can able to walk on a rope. Here we will see one textbook question. Explain why a long pole is more beneficial to the tight rope walker if the pole has slight bending. What is the use of long pole for the rope walker? You may have noticed the circus artist doing rope walking. In circus we can see circus artist doing rope walking. During this act, he will carry a long bamboo pole in his hands. He will carry a long bamboo pole in his hands. By using this, he always try to pass his center of gravity within the rope. By using the long bamboo pole, he always try to pass his center of gravity within the rope. If the artist is falling towards left, he shift bamboo pole towards right, so that his center of gravity may undisturbed. If artist is falling towards left, he shift bamboo pole towards right. If he is falling towards right, then he shift bamboo pole towards left, so that his center of gravity always pass through the rope, so he can balance on the rope. Now we will see another textual question. Why is it easier to carry same amount of water in two buckets, one in each hand, rather than in a single bucket? Here we can observe a person carrying two buckets of water, one in each hand. When we carry single bucket of water, our center of gravity shifts to outside our feet, so we may fall. When we carry the same amount of water in two buckets, our center of gravity falls within our feet. So it is easy to carry same amount of water in two buckets, one in each hand, rather than in a single bucket. Students, all of you make notes, prepare well.